I am Dr. D. M. Mahesh. Today we are going to discuss about what is a computer virus. A computer virus is a malicious piece of computer code designed to spread from device to device. A subset of malware, these self-copying threats are usually designed to damage a device or steal data. For example, you think about a biological virus, the kind that makes you sick is a persistently nasty, keeps you from functioning normally, and often requires something powerful to get rid of it. A computer virus is very similar, designed to replicate relentlessly. Computer viruses infect your programs and files, alter the way your computer operates, or stop it from working altogether. How does a computer get a virus? Even if you are careful, you can pick up computer viruses through normal web activities like sharing music files or photos with other users, visiting an infected website, opening spam email or an email attachment, downloading free games, toolbars, media players, and other system utilities, installing mainstream software applications without thoroughly reading license agreements. What are the symptoms of computer virus? Your computer may be infected if you recognize any of these malware symptoms: slow computer performance, erratic computer behavior, unexplained data loss, frequent computer crashes. Computer virus protection. Use antivirus protection on the firewall. Get anti-spyware software. Always keep your antivirus protection and the anti-spyware software up to date. Update your operating system regularly. Increase your browser security settings. Avoid questionable websites. Only download software from sites you trust. Carefully evaluate free software and file sharing applications before downloading them. Don't open messages from unknown senders. Immediately delete messages you suspect to be spam. Viruses. In 1983, American computer scientist Fred Cohen coined the term computer virus. A virus was a program that can infect other programs by modifying them to include a possibly evolved copy of it. The term computer virus refers to programs designed to spread themselves by infecting executable files, system areas, or floppy disks, pen drives, etc. without the user's knowledge. Activity viruses can perform bad actions, payloads ranging from mild disturbance, annoying the user with silly messages, to provoking damage or outright disaster. For example, deleting, corrupting files, or performing a denial of service attack. A computer is infected when a copy of the virus resides in the machine. Once the virus is loaded into the memory, it can run in background and start to replicate itself. If the infected computer is on the network, the infection will propagate very quickly to other machines. This process can be interrupted only by detection and elimination of the virus. Various types of viruses. Parasitic viruses or file viruses are core fragments that reproduce by attaching themselves to executable files. When the user starts the infected program, the virus is launched first, and then, in order to hide its presence, it triggers the original program to be opened. The parasitic virus acquires the same rights as the original program and thus is able to self-replicate and to release its payload. Worm. An internet worm, unlike a virus, does not infect other programs, files, but uses computer networks and takes advantages of software bugs to replicate it. A worm scans the network for another system having one specific security hole, such as buffer overflow, and copies itself into the new machine via SMTP, FTP, HTTP, Internet Relay, Chat, etc. and then continues the self-replication process. Thus, it has the ability to self-replicate incredibly quickly. Furthermore, the worm can release a payload such as scheduling a distributed denial of service attack toward a target system or network. Trojan horses. A Trojan horse is a program which hides malicious code disguised in appealing shapes. It claims though something cool or useful while actually provoking damages. Trojan horses are not designed to replicate automatically. Ransomware. Ransomware is a type of malware that encrypts a user files and demands a ransom for its return. Ransomware can be, but is it necessarily spread through computer viruses? Macro. Macro virus is one of the most common types of viruses for various reasons. It requires little skill to write many common applications, word processing, spreadsheet, presentation, make use of macros, and lastly documents such as reports, slides, etc. are frequently exchanged between users. Macro viruses are self-replicating macros that can become active if the user opens, closes, or saves an infected document. Recent versions of these macro enabling applications display an alert concerning macro virus risks and permit disabling of macro execution. Boot sector. A boot sector virus infects computers by modifying the contents of the boot sector program, replacing the legitimate contents with the infected version. This type of virus can only infect a machine if it is used to boot the system up. Hoaxes. Hoaxes, we have also mentioned hoaxes, which not are actually viruses, but simply messages containing false information, usually alarming, and are instructions in pseudo-technical language. Unskilled people to perform action which can provoke some damage. The user is often instigated to send this message to everyone in its address book. The result is an internet chain letter which provokes flood of unnecessary emails and wastes bandwidth, although the main platform for spreading viruses is Windows. Due to its widespread diffusion, possible infection vectors and vulnerabilities are also present in Unix, which registered a noticeable increase of bugs in open source software, Apple Macintosh, and also OpenVMS systems. The virus trend in the few past years shows that the macro and boot viruses are decreasing greatly, whereas reflecting the mutation of their habitat conditions, increase and spread of networks. Executable and worms represent the new threat. The CERT, a CC annual report for the year 2001 includes worms and DOS in the most common intruder activities, and also underlines the increasing threat of attacks against or using DNS and routers. Prevention. A few basic norms can contribute to reducing the risk of infection and to limiting damage. Computer viruses usually act with the unwitting cooperation of the user. An effective defense is having the basic skill to deal with the problem as well as the full awareness of our behavior. The use of the following basic norms throughout the organization can contribute to a very effective antivirus strategy. First of all, investing in education, making users Security aware. User education plays a fundamental role in preventing infections. Many viruses are activated by the user's unwitting complicity, double-clicking email attachments, downloading the files from the internet, etc. People are curious. They are strongly tempted to try new tools or applications. Some guidelines include: do not trust file extensions. Fake extensions can be attached to executable files in order to trick the user, that is, exe files. Damages of virus attack. Virus penetration can occur when the antivirus is unable to recognize a new virus. It is difficult to evaluate the costs that company must sustain to recover damages because they depend on many factors such as virus penetration, value of the corrupted data, recovery capacity of the organization, nature of the company business, etc. Damages are not only quantifiable in terms of money but can include time and resources necessary for disinfecting systems and restoring data and the applications. Work time lost until systems are restored. Eventual interruption of network connection and therefore possible loss of revenue, decreasing credibility for customers. Antivirus. Today the market offers a large set of sophisticated antivirus strategies. However, basic antivirus techniques include scanners that perform detection and disinfection of all known viruses. Virus signature-based systems. They are easy to use and furnish information about the virus and infected files. The main problem is that to remain effective, they must be constantly updated. Checksums rely on detecting changes. If a virus infects an object, then it changes. The main disadvantage is that they only detect infection but are unable to prevent it. In addition, checksums output must usually be evaluated by skilled personnel to distinguish between legitimate and viral changes. Heuristics antivirus. Software applies rules to detect viruses. However, heuristics analysis remains effective only if new viruses are a remake of an existing one. That is, if it uses the same method of replication. Otherwise, the rules and thus the software needed to be updated. In addition, heuristic software can mistakenly label objects as viruses when they are not, thus generating false alarms. The antivirus software and our content filtering should be set up in strategic positions where the internet traffic naturally flows, such as point of access of network perimeter. Internet or intranet gateways or routers or firewalls or proxies on the connection points between the internal networks and the internet. It is possible to check all incoming and outgoing traffic as they represent possible virus entry points. Depending on the network's architecture, the use of antivirus software or filtering rules at this level, that is for discarding unauthorized traffic, could be a way to catch or stop the virus before it enters the network and infects the system. The main problem at this level is that the encrypted files are not interpretable in transit, but only upon arrival at the final destination and the inspection of traffic content means loading the CPU. With an additional overhead that if consistent could slow down the data transit. Email servers. The antivirus software on the email server permits scanning of every incoming and outgoing message. That is, each MIME part composing the message and removal of infected paths. Also, in this configuration, encrypted files are not interpretable in transit. Servers. If the organization utilizes centrally stored shared information, that is groupware server. The antivirus software can run on this server, thus reducing the network traffic in comparison to a client-side distributed solution. User system. Virus scanning on the client side is very important. If the virus penetrates the internet gateway and our firewall and overcomes the server scanner, it could be intercepted on the user system. In addition, it must not be forgotten that a user desktop can represent a direct point of access for viruses. If he or she accesses an infected file on CD or floppy disk. However, antivirus software in a user desktop can create problems such as late program execution when the scanning is active. Another drawback of this solution, also considering the increasing use of mobile computers and the high number of clients in large organizations, is to keep the antivirus software updated. In large and complex networks, an antivirus multi-layered approach. Example, for using the antivirus in all points of access can be adapted in order to compensate for the weak. In order to compensate for the weak points of one layer with the strength of another. However, given that virus scanning shows limitations in detecting new viruses, this approach results ineffective if each layer preserves the same weakness. Therefore, different countermeasures must be applied in order to build protection levels with different features. Dear students, I hope you can understand my lessons. See you next time. Thank you.